Welcome to Chem Time. Welcome to the presentation. Today we are going to discuss the difference between heat transfer and thermodynamics and some of the principles that are being used in thermodynamics and application of first law of thermodynamics to closed system. And this presentation is useful to petroleum engineering, agricultural engineering, mechanical engineering, chemistry, and chemical engineering students. We start the presentation by highlighting the importance of today, that is 24th May. On 24th May 1790, English chemist and doctor John Davy was born, and John Davy prepared and characterized phosgene for the first time. Today, on 1680, in the year 1686, Gabriel Fahrenheit was born, and Gabriel Fahrenheit is responsible for developing Fahrenheit scale. Sir also invented alcohol thermometer as well as mercury thermometer. Sir also contributed by inventing humidity meter, that is hygrometer we call it as. Coming to the presentation, today the difference between thermodynamics and heat transfer can be understood by a term called flux. Flux is defined as driving force by resistance. This flux, wherever you talk about a transfer process, you come across flux. And while driving force is thermodynamic property, resistance is not. What I am trying to say here, if there are two sources, one at 100 degrees centigrade, the other at 20 degrees centigrade, and heat flows from 100 degrees centigrade to 20 degrees centigrade. So thermodynamics answers that there is a possibility of heat flow from 100 degrees centigrade to 20 degrees centigrade. But how fast the heat transfer takes place, that thermodynamics will not be able to answer. And that answer has to come from the subjects like heat transfer, mass transfer, and momentum transfer. And that is where the resistance term comes into picture. So the resistance term talks about how fast the process takes place, and it is not a thermodynamic property, where driving force is thermodynamic property. So thermodynamics talks about feasibility of a process. For understanding the feasibility of a process, we need to understand the properties, and also we need to understand the difference between system and surroundings. First and foremost, the difference between system and surroundings is system is the one that is under consideration, and surrounding, anything other than the system, we call it as surrounding. For example, when you are heating in a pressure cooker, the heater and the pressure cooker forms the system. These just are the items that is not part of the pressure cooker, and the heater form surroundings. And universe is the combination of system and surroundings. Further, the systems are divided into closed system, open system, and isolated system. In case of closed systems, there is only energy transfer and no mass transfer. For example, when you have a pressure cooker that is sealed along with the vessel and heated from bottom, there is energy transfer and no mass exchange. That is closed system. In case of open system, there is both energy and mass transfer. When we cook the rice in an open container, there is exchange of mass as well as heat, and that is an example of an open system. And in case of an isolated system, both neither energy nor mass exchange takes place, and this is we can see in thermos flask. Coming to the further subdivision of properties, there are two types of properties. One is extensive property, the other one is intensive property. Extensive properties depend on mass. For example, volume and weight, They are mass dependent and they are categorized under extensive properties. Intensive properties are mass independent and density and temperature are intensive properties. For making the calculations easier, the extensive property it will be expressed in terms of intensive properties. For example, both mass and volume are extensive properties. But when we consider mass by volume, it becomes an intensive property. Further, property, if it is dependent on path, we call it as path function. The property that does not depend on path, it is called point function. In case of point function, the examples are entropy and internal energy. We'll discuss about the entropy in our subsequent presentations. But internal energy is the energy possessed by the molecules of a substance. When you heat a substance, the internal energy of the substance increases. For example, if you take potatoes and heat them, the internal energy of the potatoes increases. And coming to path functions are dependent on path. For example, heat and work, they are dependent on path. And the processes can be categorized as reversible process as well as irreversible process. In case of reversible process, the process proceeds very infinitesimally slowly and does not bring any change in the environment. For example, the example of a reversible process is during the construction of a building, the bricks are transferred from one floor to other floor by means of people. This is the best example of a reversible process. Similarly, when rubber is stretched within the elastic limit, the as soon as the external force is removed, the rubber regains its original position. That is an example of reversible process. And reversible process is an idealized process. Coming to irreversible process, process cannot be reversed after removing the external force. For example, breaking of an egg in an example of irreversible process. And coming to the first law of thermodynamics that is applied to a closed system. It basically first law refers to law of conservation of energy, which all of us know, states that energy can neither be created nor be destroyed. It can be changed from one form to another. Written mathematically, the internal energy change is equal to plus or minus Q plus or minus W, where Q and W are heat and work interactions. The sign of Q and W depend whether they are added to the system or they are removed from the system. If they are added to the system, Q and W are positive, and if they are removed from the system, Q and W are negative. The concept will be explained through one of the gate problems subsequently. These are the problems we have taken. The first problem is a gas is contained in a cylinder is compressed. The work required for compression is 5000 kilojoules. During the process, heat interaction of 2000 kilojoules causes the surroundings to be heated. The change in internal the gas during the process. This is given in GATE 2024 for mechanical engineering students. Since the gas is compressed, work is added to the system and hence W is positive. And surroundings got heated, that is, heat is transferred from system to surroundings. So Q is negative. W is given as 5000 kilojoules and Q is minus 2000 kilojoules. With this, the first law of thermodynamics for a closed system gives the change in internal energy as 5000 minus 2000, that is 3000 kilojoules. Second problem is a 2 kilowatt 40-liter water heater is switched on for 20 minutes. The heat capacity of water is 4.2 kilojoules per kg Kelvin. Assuming all the electrical energy has gone into heating the water, what is the increase in water temperature in degrees centigrade? Here, as such, there is no work. The water is heated by means of an electric heater, and all the heat from the electric heater has gone into heating the water. As a result, there is no work done, and first law of thermodynamics, the W part becomes zero and delta U is equal to Q. Delta E refers to change in internal energy. The volume of water is 40 liters. We know 1000 liters is 1 meter cube and 40 liters corresponds to 0.04 meter cube. The density of water is 1000 kgs per meter cube, and therefore mass of water is volume into density 0.04 meter cube into 1000 kgs per meter cube, that is 40 kg. The specific heat of water is 4.2 kilojoules per kg Kelvin. The heater capacity is 2 kilowatts, that is 2 kilojoules per second. The heater is on for 20 minutes. 20 minutes corresponds to 20 into 60 seconds, that is 1200 seconds. So this gives us the heat added to the water, that is 2 kilojoules per second into 1200 seconds, that is 2400 kilojoules. So the Q is 2400 kilojoules, and whatever the heat is added, that is added to rise the sensible heat of water. So Q is equal to mass of water, specific heat of water, and temperature rise of water. So we need to calculate delta T, that is change in temperature. Q is given, that is 2400 kilojoules here, and water mass is 40 kilojoules, specific heat is 4.2 kilojoules per kg Kelvin into delta T. And when we calculate delta T, that is 14.3 degrees centigrade. So this is also given in GATE examination for mechanical engineering. The next problem, this is given at IIT, and this problem says one is a reversible process and one is an irreversible process from A to B, and this is shown on a PV diagram. And for this process, there are four options given. One case delta U, Q, W are same. Second option is delta U is same. Third option is Q and W are same. Fourth option is delta Q are different. We request all the viewers to tick up that, mention the correct answer in the comment section rather. Now, there are two more general questions. That is, they are mentioned here. These questions are for the viewers. Who is the richest chemical engineer in India? This is one question. Second question is, name the chemical engineer who is presently involved in IPL 2024 cricket commentary team for Star Sports. We are giving a hint. The hint is Sir was the commentator when Virat Kohli hit a six off Haris Rauf of Pakistan during 2022 T20 World Cup between India and Pakistan. The six by King Kohli is named by ICC as shot of the century. Request you to like, share and subscribe my channel.